where the work is not enclosed in a single transaction. So this is just a research problem, is that all modern ARMs have some way of managing this problem. The problem is they're usually obscure, ill-documented, hard to find, and the first round of code didn't use them correctly. So, and sometimes you need to do some re-architecture if the work is spread out over multiple methods or something like that, where it's not easily fixable. And the query train wrecks. Queries with gigantic predicates. For example, people grabbing one result set and slamming it into another one to do a large inner exists. Bad automatically generated joins. You know, this is held up as being the big problem with ORM, so actually I don't see it as often as I used to. Part of it is that if you're, the syntax for most ORMs for doing manual large joins is so god-awful, people don't want to use it. Instead, the bigger problem is that they abandon joins and start doing in-memory joins. Very large select lists. This is generally, most ORMs will request all the fields of a table back. If you start doing joins, it'll start requesting all the fields of all the tables back. This sounds bad. The reality is this tends to be a secondary problem unless there's a really huge result set, at which point the combinatorics start getting, you know, that multiply operation starts killing you. In smaller queries, yeah, whatever. Most ORMs have some way of slicing the object down, so you only get part of it back. This is more common in dynamic languages because dynamic languages tend to be more tolerant of unset fields than compiled languages. So here we're starting to get to a more general solution, which is, again, you're not going to get rid of the ORM because the ORM is providing a very valuable service to the application programmer, which is adapting the database into terms that they can understand and use in the form of an object API. But so the thing to do is, if you have to do this handcrafted SQL store procedures, wrap it in an application API. Don't expect people to just dump this raw SQL straight into their code, because it is a maintenance nightmare. They're absolutely right. It requires them to shift conceptual gears when they're reading it. And frequently, the people who understand this SQL are not going to be the people who are called in to maintain it. So what I'm getting at with this is, start thinking in terms of that the ORM is one component of a database access layer. And then now we have the join landslides, specifically joins done manually in the application. So like I said, the syntax in Django, for example, for doing a join across multiple tables is god-awful. I don't understand why people think this is an improvement over SQL, because it's this endless series of method calls to compose this gigantic object. It's really ugly. But yet, somehow this is easier than SQL. I don't get it. So they say, well, I'm not going to do that. So instead, I'm going to suck in all these tables and I'm going to do the join inside the application. And why not? Python is great. You know, one of the things that's great about Python is it's got its data structure manipulation primitives are wild. So they don't use it. And they're also sometimes not thinking in SQL terms. They're not thinking of this as a join. They're thinking, what if these data structures already existed in memory and I just had to do this correlation? So they use for loops and all sorts of exciting things. So again, and I guess there's no solution to this problem. Anyway, the solution here is either educate them about the join syntax, or again, find a way of wrapping the raw SQL inside of an API. Caching disasters. Now this is something I didn't mention earlier, which is most ORMs, not all, but most, do some kind of caching. Every ORM implicitly does some caching because the very fact that you are holding this row as an object in memory is a cache. And you have to kind of treat it that way because if something is happening in the underlying database, this cache could be invalidated. Virtually no ORMs have a mechanism for doing this. Hibernate kind of does. The active record family just ignores the problem and puts their fingers in their ears. It's like, we don't understand what you're talking about caching. So, yeah, but all ORMs cache by their nature. Anytime you have this record in memory, it's a cache of the underlying data. But they've almost done the new intelligent cache validation. It's a hard problem, first of all, and it's not a problem that's universally applicable in simple applications. You may not need this kind of cache validation. So, and being a hard problem, they figure application programmer problem. So, if necessary, you can do a read after write. This is a place where triggers and stored procedures can be very useful. Is if they have multiple access to the same row and you're not holding persistent. You can do it with locking, of course, but you really want to not do a lot of row locking if you're holding an object for read, because you're going to start single-threading the application through that row. So you can you can reread it after write or stored procedures. Another big problem is if you're using master-slave replication is how are you dealing with replication lag? In 9.0, for example, Postgres 9.0, very nice feature, which is you can do primary secondary replication, which you can do a write into the master, and then it'll replicate it out to the slaves. Well, that's great. Django, for example, has a very nice feature where you can direct the writes to one database and the reads from other databases. It works great as long as you don't expect it to be instantly rereadable. So you do have to think about how to handle this problem. Frequently you can handle this problem just by using good idioms, is understanding that when you do a write, it may be a while before this is propagated out, so don't expect to be able to do an instant read on it. So it depends on the idiom. You frequently solve this problem idiomatically, but if you're starting to get bugs in a replicated environment where the objects seem to be mysteriously changing values, that's probably what's going on. Yeah, problems with planner. This is the Java problem, because the Hibernate problem. Some ORMs really love prepared statements. Hibernate loves prepared statements. You almost, unless you're, without heroic efforts, it will do everything as a prepared statement. And the problem is, Postgres Planet, by its, this is why you like prepared statements, is that you reduce the planner overhead. So you only do the plan once a session. So you get the query, it plans it, it caches the plan. Which depends on, that is either good or bad, depending on how much you're changing the underlying parameters. If the underlying parameters are very, very similar one after another, it's a win because you didn't have to redo the replanning. If the parameters are wrong, or worse yet, this is a stored procedure that you're calling with lots of, like one of them is a hidden stored procedure, then the plans could be completely off. And unfortunately, this is really all what you have to do, is issue a discard plans to force it to release these plans if this is the problem that you're getting. Indexing problems. You get lots and lots of these. Either the columns aren't indexed at all because it's not clear. But this is one of my favorite trick questions is, what's required in the SQL standard as far as indexes go? What's the minimum requirement for index support? Trick question. Indexes aren't mentioned in the SQL standard. They are entirely an implementation feature. So if an ORM is being a database agnostic, sometimes they'll ignore indexes entirely. There are fewer and fewer, but there have been ORMs that say, oh yeah, indexes, well your DBA will take care of those. So, two other problems. You can have the wrong kind of indexes, because the syntax, frequently the syntax for creating an index is, oh, you just tag this option onto an individual field that says index this for me. That's not great if you want a multi-column index or a functional index, which is frequently a huge, huge win in Postgres. Or you have too many indexes because the application programmer just said, oh, well, I'm going to index anything that's mentioned in a query ever. And basically every single field, including giant text indexes, really expensive stuff, it has an index. So the fix here is just about every ORM has a way of dropping into raw SQL during database creation time if you're using the ORM to drive the database creation. So create the indexes there. Yeah, come back here, you. Instead of and prune down the indexes by looking at what's actually being used. This ability to issue raw SQL to create the column is very handy for doing functional indexes. And some miscellaneous debugging tips. ORM calls can be really hard to correlate with database activity. This is a very common situation, is that you see a call in the database, and you need to find which line in the application program actually did it, and it can be really complicated because by the time the ORM's done, it can kind of look nothing like the original call. I wish I had a brilliant, super easy suggestion for this, but what I tend to do is inject a lot of, in debug mode only, a lot of statements of the form select with where I am in, as a text string, just to get a trace of where it's going. If you also have access, if you can issue raw SQL, you can issue raise notifies or things like that. As an application design thing, be very liberal with these, and you can switch them off if you're running in production, so you don't get the log cluttered up with them. Turn up Postgres logging. Really use the use auto explain. Have a relatively short window for how for statement logging, and use pgfluene as a log analyzer to digest out the logs and look for really busy logs. I mean, this is good advice for database performance in general, but ORM operations usually are lazy. They usually don't happen at the point that the query is created. They happen at the point the query is executed, or the results are needed. So, and in some ORMs, it's a very common idiom to create a query and then pass it around for a while before anyone actually touches it and tries to get results out of it. Again, Django, SQL Alchemy, both of those, this is a very common idiom, is one function will create a query and then hand it over, and then some other thing will finally start getting results out of it, and it's at the point the first results are required that it's actually executed. Okay, time for another break. We'll come back at 20 till, and then conclude, and we'll send you all on your way.